Hi students, good morning to you. Welcome to this video session. My name is Samuel Dominic Chukwuemeka, aka Sam Dom for Peace, as usual. In this video session, we shall continue our discussion on sequences. In this session, we shall predict we shall write the nth term of a sequence. Sequences that are not arithmetic sequences or geometric sequences, recursive sequences, triangular sequences. So we are not going to write the nth term of those. What of other sequences? We're going to write the nth term of other sequences. So sequences that are not arithmetic sequence, geometric sequence, triangular sequence, and the rest of them. So if it is not those kind of sequences, how do we write the nth term of sequences that are not arithmetic sequence, geometric sequence, and the rest of them? How do we write those? So we're going to do some problems, and I'm going to explain to you how you can write the nth term of those sequences. Please, this is part 2 of the video playlist on sequences. So I recommend that you view part 1 and also the transcript of this video, the examples, the written examples. You can find it on this website, www.sequences.appspot.com. You can find those. You can also find them on my website at www.samuelchukwuemeka.com or www.chukwuemekasamuel.com. Alright, so let's look at some problems. We're going to solve some. So the question will be, write the nth term of these sequences. Number 1, we have 1 over 8, 2 over 9, 3 over 10, 4 over 11, 5 over 12, and it continues. With this now, we can see here that this is not an arithmetic sequence. It is not a geometric sequence. It is not a Fibonacci sequence. Some Americans will say Fibonacci. I might call it Fibonacci. That's fine. You know what I'm talking about. Okay. It is not a triangular sequence, but it is still a sequence. So if you look at this sequence here, the first term is 1 over 8. That's the first term. When you have something like this and you want to write the nth term, you might want to try to look at it and see whether you can simplify some things. So here, of course, as usual, we know that our A is the first term. A is the first term, and N is the number of terms. N is the number of terms. So here, when N is 1, okay, we see that the first term A is 1 over 8. That's the first term. When n is 2, the second term, we can call this, a subscript n to be the nth term. Let's say let a subscript n to be the nth term. Okay? So here, I know some people will say, why don't you write A1? Okay, let me write A1. A1, which is the first term. Let me now write it as A1. Okay? To please some folks. Now, A2, second term, A2 is 2 over 9. When n is 3, the third term, A3, is 3 over 10. So, you ask yourself though, do you notice something here? If you can notice something here, when n is 1, the numerator is 1. When n is 2, here the numerator is 2. When n is 3, the numerator is 3. So if you look at this, you see that at least when n is 4, the numerator A4 is 4, the numerator is 4. So you see that there is a connection with the numerator and the nth term. Now the next thing you want to know is, how do you get the denominator? How do you get the denominator? So as you can see here, this is 1 plus 7. 8 is 1 plus 7. Okay? So this is equal to 1 over 1 plus 7. This is 2 over 2 plus 7. Because the thing there is, this is a sequence. However, it is not the arithmetic sequence or geometric sequence, Here is a sequence, but other kind of sequences. So to predict the nth term, you have to do some observation. So what the skill that is being tested here is observing the terms of the sequence and the relations to that term. That is what they want to test you here, for you to be able to observe it. So as you can see here, this is 3 over 3 plus 7. This is 4 over 4 plus 7. So in that case, n term, when n is n, the n term, a to the n, is n over n plus 7. And that is the nth term. That is just the nth term. That's how you solve it. That's it. Okay, like I said, you have to observe and see the relationship. Then you can write the nth term. Okay, as you can see here, the fifth term is 5 over 5 plus 7, which is 12. Okay, now let's do number 2. So this is sequence is part 2. Okay, this is the part 2. Number 2, we have 5 over 8, 6 over 9, 7 over 10, 8 over 11, 9 over 12. So you look at this here, when n is 1, just one term, the n term a1 is 5 over 8. Right? When n is 2, a2 is 6 over 9. So let's now see if there is a connection, if there's a relationship. Let us see if we can find a relationship. Okay? When n is 3, let's write at least 3 times. A3 is 7 over 10. So you come here, this is 1. We try to see if we can find a relationship. So 5 is 1 plus 4 over 8 is 1 plus 7. 6 is 2 plus 4 over 9 is 2 plus 7. When n is 2, you want to see if, it's not a specific formula, no. You have to study and observe to see what you can deduce. Observe and deduce. What does it tell you? What does it tell you? Here, when n is 3, you see this is 3 because this is 3 terms. And A3 is the third term. N is 1 term, A1 first term. Here, N for 2 terms, what is the second term? So this is 3 plus 4 over 3 plus 7. If it works for first, second, third, then you can just manually look at the rest of the sequence. But you have to do it at least 3 times of the sequence. You have to do it at least 3 times of the sequence. Then you can visually, okay. Then you can visually do the 4th term. 4 plus 4 is 8. 4 plus 7 is 11. 5 plus 4 is 9. 5 plus 7 is 12. So in that case, the n term an will be, okay, n equal to n will be n plus 4 over n plus 7. And that becomes your answer. That becomes your answer, the nth term. Does that make sense? Comprende? Okay, let's do question 3. And you can form, nice thing with this is you can mess up, you can form your own general sequence, write the terms and try to work backwards to deduce those terms. You can play with your friend, your friend will write a general sequence and will write the n term of a sequence and will write it, close it, write about 5 terms of the sequence and then give to you and ask you to deduce that. And then you can do it also to your friend, just to play with it, Okay. Question 3. We have here 1 times 7, 2 times 8, 3 times 9, 4 times 10. You know, and you have the ellipsis. This means ellipsis. Continuous. Ad infinitum. Continuous. Keeps going. Ellipsis. Keeps going. Okay. So, you look at this here. Let's try to figure it out. When n is 1, the first time A1 is 1 times 7. Right? When n is 2, A2 second time is 2 times 8. When n is 3, the third term is 3 times 9. When n is 4, the fourth term is 4 times 10. So as you can see here, there is a relationship here. 1, 2, 3, 4. So when n is n, the n term is n times something. It's going to be n times something. Now let us try to see what it is. So we see, okay, this is 1 times 7. So we can say this as 1 times 1 plus 6. And this is something that you know, take your time, observe it, and see whether it works. This is 2 times 2 plus 6. Because 8 is 2 plus 6. This is 3 times 3 plus 6. This is 4. 4 times 4 plus 6. Some people say, come on, Samdon, talk your natural. I sing tenure and bass. Okay, I sing tenure and bass. So I'm not gonna sing. I know some people want me to sing, right? Okay. No, you see, when you're learning mathematics, you don't be always serious. I mean, be serious, but don't put in so much. Yeah. So it's good to smile, to relax. Okay. So I've been singing, I've been talking that, so I can also talk bass. I can talk bass. Okay. What is this guy saying? I can talk bass. Alright, so as you can see here, this is n times, you can see now this is n plus 6. And that is the general term, the n term of that sequence. Okay? The n term of that sequence. Alright, let's do another one. Let's do more. Let us do some more. Is it making, like, do you get it? Like, do you understand it? Makes sense, right? Question 4. Here we have 3, -6, 9, -12. Okay, how do we do this? We look at this we try to see, okay, this is not arithmetic sequence. Because if you do minus 6 minus 3 is the common difference is minus 9, but 9 minus 6, 9 plus 6 is 15. So it is not arithmetic sequence. And then it's not geometric. Negative 6 divided by 3 is negative 2. But 9 divided by negative 6 would not give you negative 2. So this is not an arithmetic sequence. It is not a geometric sequence. Okay. So let's see how we can predict the terms. I know maybe if they ask you what is the next term, the next term would be, because it looks like 3 times 2 is 6, 3 times 3 9, 3 times 4 12, 3 times 5 15. But as you can see, it alternates. This is plus, minus, plus, minus. So the next one will be 15, right? The next one will be 15. Then 3 times 6 is 18, but it will be negative 18. Do you see that? Then 3 times 7 would be 21. Then 3 times 8 would be 24. But you have to put negative 24 because it alternates. Right? So you have positive, negative, positive, negative, positive, negative, positive, negative. Now, but how do you know the nth term? So, because it alternates, let's see whether we can forget about the negative for now. Let's forget about the negative for now. When n is 1, the first term is 3. When n is 2, the second term is 6. I know it's negative 6, okay, but let's not worry about the negative for now. Let's write this out first. When n is 3, the third term is 9. When n is 4, the fourth term is negative 12. Okay, this is 1 times 3, right? And this is 2 times 3. I know it's negative 2. Okay, I know it's negative 2. We shall come to negative. We shall come to negative. This is 3 times 3. This is 4 times 3. Okay, so we know that 3 is a constant here. Okay, everybody is going to multiply by 3. N times 3. We know it's going to be n times 3. Okay, if it's going to be n, okay, an will be n times 3. But what we don't know, but then we now come to problem of negative number. We come to the problem of the negative number. That's the problem. Okay, it's now a problem. But we know that everybody must multiply by 3. Okay. Now the problem is negative number. Negative 1. So let's put this 2 times 3. Then let's put this as negative 1. Let's put this as negative 1. Okay. If it is odd, if it is the odd 10, then it's 1. It's times 1. If it is the odd term, it's times 1. But if it is the even term, it is times negative 1. If it is the odd term, it is times 1. But if it is the even term, then it's times negative 1. Why is that? And if it was maybe odd term -1, even term 1, it will be easier for us. Okay, we can do that next as question 5, so you see it. But here is the odd term, the odd term is 1, even term -1. So it becomes problem. It becomes problem. See what I mean here. Okay, this is 4. We shall still come to this. We shall come to this. I want to show you. Number 5. So you see what I'm trying to explain. If I have number 5 here, -3, 6, -9, 12, -15, 18. So here, n is 1, a1 is -3, n is 2, a2 is 6, n is 3, a3 is -9, n is 4, a4 is 12. So what I'm saying is this. Let's say we have this as 1 times 3. Let's forget about the negative for now. This is 2 times 3. This is 3 times 3. This is 4 times 3. Okay. Now this here is times -1. This is times 1. This is times -1. This is times 1. So with this here, it is easier. You know why this is easier for us? Because with this here, all we need to do is, we can say 1 times 3 times -1 raised to power 1. Because -1 exponent 1 is -1. When you have a negative base to odd exponent, it gives you 1. Sorry, it gives you a negative result. I'm sorry. When you have a negative base to odd exponent, it gives you negative result. When you have a negative base to even exponent, it gives you a positive result. Okay, we explained that in the videos on exponents. Okay, you have a negative base raised to odd exponent, always gives you a negative result. You have a negative base raised to even exponent, always gives you a positive result. So because this is now 2 times 3 times -1 all squared. Because -1 all squared is 1. See that? And this will be 3 times 3 times -1 all cubed. -1 all cubed is -1. And this is 4 times 3 times -1 all raised to power 4. So you see here that here the n term is n times 3 times -1 exponent n. This is the n term for this. Here. However, you see this one is pretty straightforward. However, with this, you have to figure out, you ask yourself, what are you going to do in this case? Okay, we have to make sure that even will be multiplying by -1. Excuse me. So you say, okay, why don't I raise, because you cannot raise it 1 raised to power. You cannot have 1 as the base. It's got to be something -1. Okay, raised to odd exponent, raised to even exponent. This is straightforward. But with this here, you do more thinking. So you can say, okay, let's say we have this as 1 times 3 times negative 1 raised to 1 plus 1. Because negative 1, because you can't have only 1, no matter what. Because 1 exponent anything is 1. 1 exponent odd is 1. 1 exponent 1 to 1 raised to odd exponent is 1. 1 raised to even exponent is 1. But negative 1 raised to odd exponent will give you negative 1. Negative 1 raised to even exponent will give you 1. So you ask yourself, you can't have 1. You have to think about it. It's not like, you have to think about it. So this, you can say, okay, since this is 1, we can say negative, because of this negative ones, it becomes problems. It becomes a problem. So you say, okay, I'm going to include negative 1, but how do I do it so that it gives me 1? So we can say here, 1 times 3 times negative 1 raised to 1 plus 1. So we keep adding plus 1 in the exponent. And as you can see, this is negative 1 all squared, and that gives you 1. Here you can say 2 times 3 times negative 1 exponent 2 plus 1. Because 2 plus 1 is 3, negative 1 exponent 3 is negative 1. Okay? Here you can say 3 times 3 times exponent 3 plus 1. Okay? Now remember, it is just this 3 that is constant. The rest changes. The 3 here and then plus 1 in the exponent. They are the constants. Here this will be 4 times 3 times negative 1 exponent 4 plus 1 to give you that. So what would this now be? This will be n times 3 times negative 1 exponent n plus 1. And this becomes your answer. And this becomes your answer. Okay? Alright, good people. We are going to stop here for today. If you have any questions, you can ask me. Thank you so much for listening, and you have a good day.